everyone and welcome to my video. This one is going to be about how do aeroplanes fly if they're so heavy? And I chose this question because I know it goes around to millions of people around the world, and I've actually been thinking about it so much. Like, they're huge and they're heavy. So how? And before we get into our video, let's start with telling you guys something, which is every Sunday we have a special video where you are going to get to meet Ikra and Afia with me, and we're going to make a video together. So you're going to love that. So let's start with the big question. Aeroplane wings are not perfectly flat. They are slightly tilted upward when the aircraft is in motion. This tilt is called the angle of attack, the angle between the wing and the oncoming air, and it plays a crucial role in generating lift. When the wing is angled correctly, it forces a larger amount of air downward beneath it, creating an equal and opposite reaction upward due to Newton's third law, also known as for every action there's an equal and opposite reaction. At the same time, the shape of the wing speeds up airflow over the top surface, lowering air pressure above the wing and increasing lift below it. So even a small change in this angle can drastically affect performance. Too little angle reduces lift, while too much can cause a stall. Also, a stall is a sudden loss of lift when airflow separates from the wing. This precise balance is why pilots must carefully control the aircraft's pitch during takeoff and landing. So now you know how the aeroplane actually goes up in when you're going on holiday or whatever you're doing. So now let's look at why airplanes don't fall from the sky. Well, they're heavy, they are massive, so how? Airplanes are constantly being pulled downward by gravity, meaning they are always in a state of controlled descent in theory because the Earth pulls gravity. The, the Earth's gravity is strong, so whenever we jump, we go back down because of the gravity pulling us down. However, they remain airborne because they continuously generate enough lift, which is the upward force created by air pressure differences across the wings, to contract the weight, the force of gravity acting on the aircraft's mass. This lift is sustained by forward motion, which is produced by the engines generating thrust, a forward driving force created by jet engines or propellers. As long as thrust keeps the aircraft moving, a sufficient speed at sufficient at a sufficient speed, well, air continues to flow over the wings in a stable pattern, maintaining pressure differences that support flight. If the speed decreases too much, lift weakens and the aircraft can enter a decent downward movement due to gravity overcoming lift. Therefore, flight is not about eliminating gravity, but about constantly balancing multiple forces in real life time to achieve stable airborne motion. Now that we know that, let's look at the main points we're going to recap in this video. Air pressure and flight, thrust and engine power, and finally drag and air resistance. So let's start with the air pressure and flight. Air pressure is the force exerted by particles pushing on surfaces around them. When air moves faster over the top of a wing, the pressure becomes lower compared to the bottom. This difference in pressure creates lift, upward force caused by pressure imbalance, which helps the airplane rise into the sky. Without air pressure differences, flight would not be possible. Now that we know about the air pressure, let's look at the thrust and the engine power. Thrust is the forward force produced by airplane engines. Jet engines work by taking in air, compressing it, and pushing it out at very high speed, creating a strong forward push. This forward motion is essential because without it, there would be no airflow over the wings to create lift. In simple terms, engines do not do engines do not lift the plane, they keep it moving fast enough for flight to happen. Now we know all about the thrust and engine power, so we'll look at the final point, the drag and air resistance. Drag is the force that slows an airplane down as it moves through the air. It is caused by air particles pushing against the body of the plane. Engineers design airplanes with smooth curved shapes to reduce drag, which is called being aerodynamic, which is designed to reduce air resistance. Less drag means the plane can fly faster and use less fuel. So why aeroplanes can fly through bad weather is the next thing we're going to talk about. So although severe weather can be dangerous, airplanes are designed to operate in many different conditions. Modern aircraft are built to withstand strong winds, rain turbulence, and low temperatures. Pilots receive weather information before and during flight so they can avoid the most dangerous areas. Airplanes are also equipped with radar systems that help detect storms ahead, allowing pilots to adjust their route when necessary. So the science behind gliding. One surprising fact is that airplanes can continue flying even if the engines stop working. This is because the wings still generate lift as long as air is flowing over them. In this situation, the airplane becomes a glider, slowly losing altitude while continuing to move forward. Pilots are trained for these situations and can often guide the aircraft to a safe landing area if necessary. So I hope you learned a lot in this video and thank you for watching. I hope you really learned that question, how do airplanes fly if they're so heavy? Hope to see you in the next video. Remember, please like and subscribe for more videos and for more limited edition videos, which is with Ikra and Afia, as they are the funniest chaps you'll ever meet. Thank you and bye. Hope to see you in the next video.